All right. Welcome back to the second part of the CQ series on Kedika OER. I remind you on the first part that we spoke extensively about the Cartesian plane. And now we're going to be more general, meaning I'm not going to set myself to a specific context. Whatever these numbers represent, they're just numbers, but maths is not about numbers actually. Numbers are just way of making the arithmetic meaningful. What is more important in mathematics is concepts, and these are the concepts that I want to discuss. And the key concept here is this one. And it's the relations of it's the concept that is going to make us understand what we mean by the intercepts. Remember when you started with the Cartesian plane, we brought it in order to describe an object in real life using our Cartesian plane. And we set a standard that we are going to describe it firstly in terms of our primary axis, which we label as the x-axis, and then what I call the secondary. Now I want to bring in another term. Maybe it's too early, but so that you get used to it. This is called the domain. Right? I'm going to use them interchangeably so that you get used to this. But primarily, I use the term so that to keep on reminding you that it's a starting point, meaning a coordinate of this object can be given in terms of the x value and the y value. That's the syntax. That's how we write it. Right? So with this point, the x value is 3, and the y value is 2. Right? Now, it's a point, just like any other point. It's literally a point. There are many points here. Many points. And I'm just selecting them randomly. There are millions of coordinates here. I'm just selecting one. But the mere fact of selecting one, if you highlight one, right, forget about these ones forget about this. If you select one and you give it the primary value in terms of which is x and the y value, you have started what is called the relation itself, meaning you have related the value of 3, x is equals to 3, to the value of y is equals to 2. You have started a relation. You are saying you are not interested in this point here. That's why it's not highlighted. There's nothing there. Right? However, when you do highlight it, and we see it with our own eyes, and we find that the x part of it is 1, and associated with this one is the value 3, this 3. It means you were interested in this point for whatever reason. Meaning you have related 1 with 3. If I look at your Cartesian plane, I will tell you that you have related 1 with 3 and 3 with 2. That's all I can tell you until you select another one. What if there's 1,000 of them that you want to select? Well, let's select the simplest one. Let's select the simplest one. This is the simplest one. It's a straight line. Meaning there's a point at each and everywhere in this line. There's a point, there's a coordinate. I'm just selecting a few, such that this value of x is equals to -3 is associated with this value of y. Hence, it's a coordinate. There are many coordinates on this line. The line itself relates specific values of x. Specific values of x. I can choose anyone with specific values of y. Specific values of x with specific values of y. It's a selection of points, many of them, such that we just draw a line. Now, what I'm saying about a line, what you call a graph, what this can be called a graph, is going to apply to every type of graph. And I mean every type of graph, guys. Just that basic notion. So in the second part, I'm going to bring an algebraic representation of this, which we are going to call an equation. But let's take it one piece at a time. Let's also observe something else. Now, as I drew this graph, we've got our y and x. These are our keys. These are our starting points, reference of measure. Whatever x represents. X could be distance, x could be quantity of things, number of people. We have detached ourselves from the context. We are now general. We are at the level of abstraction. When I drew this line, our axes were there. And when this line started cutting the x-axis, the primary axis, let's say here, right at this point, it's a point on the line. But because it cuts the x-axis, we call it the x-intercept. And this one here, we call it the y-intercept. But you and I know that it's a point on the line, and it's got coordinates. Just like this one has got coordinates. It's just that this point is not on the line. It's just a point on the plane. Meaning, with the value of 3, we associate 2 relative to this point. Now this one, the coordinate will be 0, 2. Right? Meaning with the value of x is equals to 0, we associate it with y is equals to 2. Here we say with the value of -2, we associate with 0, the coordinate of this point. It's a point. It's a coordinate with a special name that is an x-intercept. And this is a y-intercept. Now you say, well, what if it was not a line? Fine. Let's bring in a... which color should I use? What if it was not a line? I'll use the black color. Where are they? There's my y-intercept. And it's happening exactly at x is equals to 0. Just like this y-intercept happened at x is equals to 0. Meaning on the y-axis. These are my... Did I say x-intercept? That's my y-intercept. It's happening at x is equals to 0. These are my x-intercepts. These guys. And all of them have got the value of y is equals to 0. Whatever the x is, here it could be whatever this value of x is. These are the x-intercept. These are the x-intercept. That's it. Period. And they are all happening at y is equals to 0. The x-intercept. The y-intercept is happening at x is equals to 0 itself, whatever the value of y is. I'm just putting it general. It's just a value. Right? I can select one from this. But I want to throw in a term that these values of y are referred to as function values. And we precisely state that they are values of the function values. Values of a function. Using this example, at x is equals to 3. Meaning I'm talking about the point. I'm saying 2 is the function value at x is equals to 3. I still need to make mention, even if I start with a function value in my statement, I need to make inferences to the x, to the primary. Or I can say at x is equals to 3, the function value is 2. There it is, the function value is 2. And you can speak about these other guys. Now, I would interest you on other things, which are just right in front of our eyes. These points here are special points. They've got a name. That's where the graph tends. You'll do it for the others. They're called turning points. Meaning the graph is turning. It was going down, now it's going up. If we look at this as up and this as down, it's changing direction. Whether you call this up, whatever you call up, because my up could be there. The fact is, it's changing direction. Right. When it's going to the negative, we say it's decreasing. When it's going up, we say it's increasing. So it's increasing, decreasing, increasing, decreasing. So usually the increase we specify as a plus to say it increases. And we look at it from left to right. We look at it from left, we analyze it from left to right. We say, as I go from left to right, between these two values of x, it's increasing. As I continue to the right, between these values of x, it's decreasing. Or, up to here, it's decreasing. And then it starts to increase, and then it's. So you can talk about a graph. You can tell me what the function values are. When I say increasing, I mean the values of y's are going up. The function value. Increasing and decreasing, or decreasing. Speak about the function value, meaning these guys. The values of y, the function values, the values of a function are going up. As I go from left to right, as I increase, it also increases. Or as I increase from left to right on the x-axis, it's going down. So I could be asking, where is the function? Did I call this a function? Should have called it a graph. No? Here. Where is this graph decreasing? Where is it increasing? So you'll specify it in terms of the intervals, and we'll do that in lecture 2.